Alright guys, low budget film here. Not the prettiest thing in the world, but I think it'll work. You're getting ready to do some source activity calculations in your syllabus or those calculations that you have online. First thing here, I guess, sorry about the dress, I'm not the prettiest thing in the world. And it's summertime, so you get t-shirts instead of button-up shirts. But, past that, let's get this happening here. You're going to do some source activity calculations. There's a couple of things you need to know first. The source activity, all that is a regular curie strength of 100 curies, 85 curies, 6,000 curies, it doesn't matter. If we're working a half-life formula, all we're trying to do is make sure this thing is decaying at a constant rate. If we have iridium 192, and you've seen this in your book already, if you have iridium 192, the half-life is 75 days. That means that if you had 100 curies of iridium 192 today, 75 days from now, it would only be worth 50 curies, or only have the strength of 50 curies, because, as you read, half of those curies have depleted or disintegrated. Okay, there's the becquerels and all those conversions that you guys have done so far. So, onward and upward with that. If you're using cobalt 60, it is 5.3 years. Okay? So, no worries there. I'll work a couple of these out here. You guys can go back kind of working with me on your calculator, sitting there in your at your computers in your PJs. So, here's the first one written out. 85 curies of cobalt, 1.6 years old. How many curies today? If I was running my calculator, I would push this button sequence. 85 divided by 2. So I'm doing that, 85 divided by 2. Okay, do not hit equals. Repeat, do not hit equals. Then you're going to want to come up to a button like this. It's either going to say Y to the X, or it's going to be a little rooftop looking thing. A caret key is what some people call it, depending on the type of calculator you have. It needs to be at least a scientific calculator. That makes it work the best. So I'm just going to use a little caret guy. That's what my calculator has here. So I push, so far, 85 divided by 2 to the power of, okay, parentheses, okay, open parentheses there. That's going to raise this up to an exponent. We have 1.6 years old. We're using cobalt. So we're going to use this as our standard number. So inside that parentheses, we're going to put that 1.6, and we're going to divide that 1.6 by 5.3. Close the parentheses. Okay? 1.6 divided by 5.3, close parentheses, equals, you should come up with a value of about 68.95. If you round that up, we can say 69. Okay? And that is a curie strength. So, that one shouldn't be too bad. Next one, I'm just going to write the numbers out. That'll make it easier. You can see it there on your worksheet. 162 curies of iridium. So we'll say 100, if I can write here, 162 curies iridium. And then we've got 360 days old. And then we've got how many curies today. So we'll say days, and we'll say curies today. So, here's our formula. We're going to say 162 divided by 2 to the power of, open parentheses, 360 divided by 75. Because we've got days, we've got iridium, and we've got days. Okay? So, punch that into my calculator. 162 divided by 2 to the power of, open parentheses, 360 days divided by 75 days, half-life. That tells me I have about 5.81 curies of iridium. Okay? So, shouldn't be too bad. If you have questions or you think you need help with those, go back, watch that video again. Shouldn't be too bad. I think that should definitely help you out. That's the first one. I'll have a series of videos here. So, low budget films again. My apologies, but that's just how it is. So, here we go.